Identify rates of change or slopes from given linear functions. Now, a linear function is a function whose graph is a line, but that line cannot be vertical. Linear functions can be written in the form of f of x is equal to mx plus b. M, that's the slope. That's what we want to be able to identify today in this lesson. And b is the initial value of the function. And when graphed, it represents the y-intercept. So what you see in front of you is a bunch of lines that are sketched. And when you take a look at the equation of a line, you know you have the slope when you read off the coefficient for x. So if I take a look at these lines, what I notice is that the positive slopes, which I see here, 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 and here, are all increasing functions. And in fact, the greater the actual value of the slope, the steeper the line. And what I see here, which is, again, 3 more lines graphed, are lines with negative slopes. These lines are decreasing. And again, if I took the absolute value of that slope, the greater the slope, the steeper the line. So all I want to do is take an equation that I have in front of me that represents a functions equation, and from it read off the slope. Remembering that the coefficient of the input variable is going to give me that slope. So I have 3 different functions in front of me. And I want to remember that all I'm going to do is write these functions so I can clearly see f of x is equal to mx plus b. So I can read off that coefficient in front of x and call it the slope. I say I'm going to do this, but you're going to do this, right? You're going to do this. The first function is f of x. It seems like it's already written in this form. I'm not trying to give you a hint, but identify the slope. It would be what? It would be
2.
It would be 2 because it's the coefficient in front of x. So the slope is 2. Very good. Now for the second function, g of x, what I want to do is rewrite it so I can see the form g of x equals mx plus b. So go ahead and rewrite it so I can see that coefficient clear as day. I would write g of x is equal to.
Could you do negative 1/3 times x?
Very good. And then
plus 7.
And then plus 7. Good. Now I can read off my coefficient in front of the x. What would that be? That would be
negative 1/3.
Very good. So I have m is equal to negative 1/3. In my very last function, h of x, again I want to rewrite it. I say I would like you to rewrite it so that it's in the form of mx plus b. So I can read off the coefficient in front of x. So I would rewrite it as h of x is equal to.
Would it be 0 times x?
Very good.
And then plus 9.
Then plus 9. And now it's in the right form because 0 plus 9 is 9, and that's what we have. Now for the easy part of the question, which is what is the slope for this line?
0.
0. That's excellent. Thank you. Solve applications involving linear functions. Now we know a linear function is defined as a function with a constant rate of change. Linear functions may be written in the form of f of x equals mx plus b, where m is the slope, and that's the constant rate of change, and b is the initial value, or the y-intercept of the line when it's graphed. So whenever you read through these real-world problems with linear functions, you want to see if you can first verify that it is linear. Can you recognize the constant rate of change? And is it possible in the problem to recognize the initial value? So that when graphed, that would be the y-intercept. So the problem we have here, I want to read through. But as I read through, I'd like to ask you to see if you can recognize the constant rate of change and the initial value. And then can you recognize what the domain and range would be from this linear function? So initially a business incurs $80,000 in startup costs for space and supplies and that type of thing, and then finds itself spending $5,000 per week on supplies and labor. Now we're going to ask 2 questions. We want to write a linear function that yields the cost that's incurred by the company after X weeks, and we want to determine the cost incurred over the course of 1 year. Now, when I look at this exact same problem, I'm going to ask you to see if you can come up with the constant rate of change. Where do you see a rate of change here?
Is it the 5,000 per week?
Very good. So that is a change of $5,000 for each week. So I'm just going to write that in. 5,000 per week. I'm just going to abbreviate week. Is that okay?
That's
Yeah.
okay with me.
So the slope is really a constant of change of output per change of input, which in this case is a change of output, $5,000, per change of input per 1 week.
Right.
Slope itself, the numerical value would be what? It would be
5,000.
5,000. I'm going to write that in as well. Now, domain and range. The cost itself depends on the number of weeks passed. So think about domain and range. What would the domain be?
Would it be from 0 to infinity?
I didn't ask that question very well. What is the actual real-world meaning of domain here? What is it measuring in this problem?
Oh, just weeks past?
Weeks passed. Very good. Okay, so it's the number of weeks. What's the range going to represent?
The costs.
The cost incurred for X number of weeks. So I'm just going to write that in. Now, if you're curious how you arrive at that, because you seem to get it just fine, if you're curious how to arrive at it, you can go back to slope, because slope is a change of output per change of input. So it would be the units of the output over the units of the input. And we're reading that right off of here, dollars over weeks. Now, finally, let's go ahead and take a look at initially. That means when X is 0. So when what is 0? Is it the cost of the number of weeks?
The number of weeks.
Number of weeks is 0. The business incurs what? It incurs a...
$80,000 cost.
Very good. I'm going to write that in. $80,000 startup cost. Excellent. So evaluating that particular function, C of 0 would equal 80,000, and that value of B, therefore, would be?
80,000.
80,000. Well, now what I want to do, so I flipped the page a little bit too quickly, I want to write the linear function. So I think I can write the linear function. I would have C of x is equal to mx plus b, and I just want to substitute in the slope and the intercept, y-intercept. What would C of x look like then? What would that linear function be?
C of x equals 5,000x plus 80,000.
Excellent. Now I have my linear function. Now we'll go to part B. And part B says I want to determine the cost incurred over the course of 1 year. Refresh my memory. The input represented what in this problem?
The
weeks.
Number of weeks. So when I have a time reference of 1 year, I'm saying the input value that I would use to represent 1 year would be?
So there are like 58 weeks in a year?
Almost, but no.
64?
52.
52. I knew you'd hit it eventually. That's great. The output is the cost, right? So what I want to do is evaluate this function. Do you remember what the function was?
5,000x plus 80,000.
Let me write that down. And I want to evaluate this cost at what? At
X equals 52.
Very good. So I'm just going to substitute in a 52 for that value of x. Can you do that on the calculator and tell me what you get? We can find the cost that's incurred over the time frame of 1 year. So we have C of 52.
340,000.
Very good. It's $340,000. Excellent. Thank you. If y equals f of x is a linear function, and 3, negative 2, and 8, 1 are points on the line, we want to find the slope. Is the graph of the function increasing or decreasing? So for slope, I'll use the variable m. And what is a slope? Well, a slope is a change of output, so I'll use a triangle to represent change of output per a change of input. So let's go ahead and do this calculation. For the change of output, I'll subtract the y-coordinates. I have 1 minus a negative 2. So for the change of inputs, well, I'll subtract the x-coordinates in the same order. That would be 8 minus 3. So it looks like our slope is going to be 1 plus 2, which is 3, over 8 minus 3, which is 5. Now this slope that we have is positive. And whenever the slopes are positive, the function is going to be increasing. This linear function is increasing. If the slope was negative, well, then the linear function, its graph, would have been decreasing. Find linear functions from given points or a point in a slope. If I'm given a point and a way to get the slope or the slope outright, I can use the point-slope form of a line. To remember exactly what that form is, I'm going to derive, albeit quickly, that particular form. And the way I'll do that is I'll go ahead and pick 2 points and write down the slope formula for it. But I'm going to pick the points very carefully. And what I mean by that is I'm going to go ahead and say that if I have x, y, this refers to just a arbitrary point on the line. Arbitrary point on the line. And x1, y1 would be a point that I actually give you. So it would be a specific point on a line. So I'm going to write my slope formula, and that's my change of output per change of input. So it would be y minus y1 over x minus x1. And if I multiply both sides of the equation by what I see in the denominator, so I'll multiply both the left side and the right side by x minus x1. Notice on the right side, the x minus x1's cancel, and what I'm left with is a pretty big deal. And what I'm left with is that m times x minus x1 is equal to y minus y1. And this is your point-slope form of a line, where x and y are your variables, and the x1, y1 would be a point that's given to you. So we would go ahead and give you x1 and y1. We would give you a way to get the slope, and the x and y would be the variables in the actual equation. So let's go ahead and use this point-slope form of a line to find a linear function whose graph passes through these 2 points. And the 2 points that we have are negative 2, 3 and negative 4, 1. So let me switch over to pen and we'll do this. First thing I'm going to do is identify one of the points as the specific point. So that'll be x1, y1. And I'll choose the first point, negative 2, 3. Once I do this, I'm going to say to myself, all right, if I have y minus y1 is equal to m times x minus x1, I'm going to start my substitutions immediately. What will I put in place of x1? I'll put what? I'll put
Negative 2.
All right, so I'm going to just mark that. And what would I put in place of y1? I would put
A 3.
a 3. Now the next thing I have to do is find the slope. In this case, I'm not given it. But I know how to find the slope, right? I can find the slope how? I can go ahead and say my slope is my change of y over my change of x. So my change of y, if I go ahead and list x2, y2 as the other point, so that would have coordinates 4, negative 1, change of y would be y2 minus y1. What would y2 minus y1 look like as a calculation?
That would be negative 1 minus 3.
Let me write that down. over x2 minus x1. What would that look like as a calculation?
That would look like 4 minus negative 2.
Very good. Now, negative 1 minus 3 is?
Negative 4.
Remember that number? 4 minus a negative 2 is 4 plus 2. That number is?
6.
So the numerator is?
4.
Positive or negative?
Negative 4.
Negative 4, and the denominator is?
Positive 6.
Positive 6. So it looks like we have a negative 4/6. So I can reduce that, I suppose. The slope would be what the slope would be?
Negative 2
2/3.
thirds.
Excellent. So where will I go ahead and make that substitution? I'll make that substitution in for m. M would be negative 2/3. Now we have all the players that we need. So let's go ahead and use our point slope formula. So I'll have y minus y1, which is?
Which is 3.
3, good, is equal to m, which is?
Negative 2 thirds.
Good, times x.
Times x minus x2, or x1, which is negative 2.
That's super. Let's see if we can clean this up a little bit. We have y minus 3 is equal to negative 2/3 times x minus a negative 2, which is x what, x?
Plus 2.
Plus 2.
Plus 2. I'm going to follow the calculation here, if that's okay.
It's okay.
And I'm going to distribute the negative 2/3 to both terms, except I'm not going to do that. You're going to do that. So I have y minus 3 is equal to?
Negative 2/3 x minus 4/3.
Very good. Negative 2/3 times a 2. I'll just do that. Calculation up here is times 2 over 1. And that's the negative 4/3 that I heard. Beautiful. So I'll write minus 4/3. Now I want to write a linear function, so I'm going to solve for y and call it f of x. Well, I can do that. If I solve for y, I'll add a 3 to both sides of the equation, which gives me y is equal to, or f of x is equal to, negative 2/3 x. Now if I add a 3 over, what does that calculation look like? It looks like negative 4/3
Plus 3.
plus 3. That's super.
Which would be 16 thirds.
Which would be, let's see. So I got negative, what was it? Negative what? Negative?
Negative 4 thirds.
Negative 4/3 plus 3, which I'll write as 9 over 3.
Ah, I see.
And that would be what?
5 thirds.
Very good. So I'm just going to make a note of that. So it looks like now I'm ready to just finish this problem. It looks like I have negative 2/3 x plus what? Plus
5 thirds.
plus 5/3. Can you remember that function for me? Can you memorize it for me? Can you do that okay?
I can write it.
Let's go to the next slide. Oh, there it is. Did you write it? Because there it is right there. And there's the graph of the function. Let's see if we can find our points. We have negative 2 comma 3. That's here. 4 comma negative 1 here. And we've gone ahead and graphed it. Thank you. We want to write the point slope form of an equation of a line with slope 3 that passes through the point 6, negative 1, and then we'll rewrite it in the slope intercept form. So let's go ahead and start with the point slope form itself. That form is y minus y1 is equal to m times x minus x1. Now, when I go ahead and look at the information that's given, I know that my point that I'm given, well, that's x1, y1. And I know my slope, that's the m. That's 3. So in place of y1, I'll go ahead and substitute in a negative 1. In place of m, I'll substitute in the 3. And in place of x1, I'll substitute in the 6. Making the substitutions, I have y minus a negative 1 is equal to 3 times x minus 6. Well, y minus a negative 1, that's the same as y plus 1. So now I have y plus 1 is equal to 3 times x minus 6. That's my point slope form of an equation. To find my slope intercept form, well, I know that form is y is equal to mx plus b. So that means I'll take my point slope form, which I know is y plus 1, is equal to 3 times x minus 6, and I'll solve for y. So the first thing I'll do is on the right side of the equation, I'll distribute the 3. So this gives me y plus 1 is equal to 3x minus 18. Now I'll subtract the 1 from both sides of the equation, and this gives me y is equal to 3x minus 18 minus 1, which is y is equal to 3x minus 19. And there is my slope-intercept form. Write the point-slope form of an equation of a line that passes through the 2 points shown below, and that's 5, 1, and 8, 7. And then we want to write the equation of the same line in slope-intercept form. Now for point-slope form, which is where we'll start, point-slope form is y minus y1 is equal to m times x minus x1. So let's begin by labeling 5, 1 as x1, y1, and 8, 7 will be x2, y2. And we're going to substitute in for x1 a 5. For y1, we'll substitute in a 1. And we're going to have to find the slope. So to find the slope, m is equal to y2 minus y1 over x2 minus x1. Change of y over change of x. Change of output over change of input. So y2 minus y1, that would be 7 minus 1. x2 minus x1, that would be 8 minus 5. So it looks like we have 6 over 3, which reduces to 2. That's what we'll substitute in for m. So we have y minus y1, which is 1, is equal to m, which is 2, times x minus x1, x minus 5. And we have our point-slope form of a line. To find the slope-intercept form of the line, all we do is we'll go ahead and solve for y. Because if we solve for y, then the form of the line would be in slope-intercept form. We can see the m and the b clear as day. So if we solve for y, I'll distribute the 2 first. I'll have y minus 1 is equal to 2x minus 10. And then I'll add a 1 to both sides of the equation. This gives me y is equal to 2x. And then we have negative 10 plus 1, which is negative 9. 2x minus 9. And here is our slope-intercept form of a line. Identify functions as linear or nonlinear. So our goal is to be given a function and determine if this function is linear or not. Well, what's a linear function? It's a function that has a constant rate of change, slope, given by m, and it's a polynomial of degree 1, which means the exponent on x must be 1. So to actually determine if you have a linear function, your eye goes to 2 places. Do you see a constant rate of change, which is the coefficient in front of x? And is this polynomial of degree 1? In other words, is there only one term with x, and the exponent on that x is a 1? Now here are 2 examples of linear functions. F of x is equal to 2x plus 3 is linear because the exponent on the x is a 1, and we have a coefficient 2, which tells us our slope.
Right.
If I go ahead and take a look at g of x, which is equal to negative x over 2 plus 1, if I take a moment to rewrite g of x as negative 1/2 times x to the first plus 1, very quickly I see my exponent on the x being a 1. It's the only term with an x. And the coefficient as negative 1/2. Now we're going to go ahead and see if we can go find which of these 4 functions are linear. Your eye goes to the function, you identify only one term with an x. The exponent on that x must be a
1.
A 1, and you clearly see the coefficient.
Right.
So go to the very first function, y equals 5x plus 6. Is this a function that can be rewritten in the form of mx plus b? Is this a linear function?
Yes.
Looks like it is.
Yes, it is, because the exponent on the x is a 1, and your slope is a
5.
5. Go ahead and look at the second function. Is it a linear function?
Yes.
Yes, because if I rewrite it as,
1/5 x plus 6.
very good, the coefficient of 1/5 is the
Slope.
slope, and the exponent on the x is a
1.
1. Go ahead and look at the third function. Y is equal to 5 over x plus 6.
Right.
Can I rewrite it in my form f of x equals mx plus b?
You can.
I can? Okay, so I'd have y is equal to, what's the coefficient?
That's a good question.
Thank you, I came up with it
It
all by
would be-
myself. What would be the coefficient?
Wouldn't it be 5x
It'd be
to
5.
the negative 1?
Very good, but it's a coefficient for the term x to the negative 1. That's very good. And then plus 6.
Plus 6.
So I do have my coefficient, but notice the exponent is what? The exponent is
Negative.
negative 1.
Negative 1.
That negative 1 is not a 1. It's probably the silliest thing you've heard all day, but that's crucial. That means that what we have here is not a linear function. So I'm just going to write that down. It's the first time I came up with something that was not a linear function. Let's take a look at the very last function. And if I go ahead and take a look at it, I say to myself, is this a linear function? Your reply is,
No.
no, I don't think I need to rewrite it because what is the diagnostic feature that tells me it's not linear?
It's not of degree 1.
It's not of degree 1. The degree is what? The degree is?
2.
2.
The exponent on the x is a 2. Very good. So this very last function is not a linear function. Now I got to go back to the way my question was phrased just to make sure I'm understanding what's being asked. And what was asked is which of these functions may be classified as linear functions. I guess it would be this one and that one. Those two, huh?
Right.
Yeah.
Thank you. Identify rates of change or slopes from graphs or tables. What we're going to do is give you linear functions, but they'll be represented in graphical form and then in table form. And from the graph and from the table, I want to be able to see if I can identify the slope. I want you to be able to identify the slope, actually, right? So to remind ourselves, a linear function f of x equals mx plus b, m is this constant rate of change, b is when graph this line, that b is the y-intercept. So the slope is the change of output per change of input, and that's actually very important. So when I take a look at all these lines in front of me, my positive slopes are increasing functions, my negative slopes are decreasing functions. The larger the absolute value of the slope, the steeper the line. So the first thing we're going to do is just simply look at a graph and see if we can find the slope of the linear function whose graph is shown. So what I have to do is I have to fixate, I have to find. It's kind of like searching for a person in a big old crowd. I want to find 2 points that I can identify. Except I don't want to do that, I want you to do that. So I'm going to switch to highlighter, see if I can pick a nice color. How about blue? Do you see the coordinates of 1 point that you can clearly identify?
Absolutely. I see 0, negative 1.
Let me go ahead and put a big old dot there. And a second point.
1, 2.
Beautiful job. I'm going to switch over to pen mode and see if I can grab a color that stands out. I'm going to write in those coordinates. And coordinates of 0, negative 1 was read to me. And coordinates of what? Of
1, 2.
1, 2. So one way to find a slope is with the slope formula once you grab the coordinates right off the graph. Slope formula takes the change of y over the change of x. 2 minus a negative 1. That's the change of y over...
Change of x, which is 1 minus 0.
Beautiful. And what do we get for a slope here? We get a slope of?
Of 3 over 1.
3 over 1. Very good. The other way to recognize the slope from the graph is once you have identified the points, instead think of the slope as rise over run. It's a familiar phrase that many of you may have heard of. And what we do is we start at 1 point and we notice that we go up 3 units, that's my rise, and over or to the right 1 unit. So my slope is up 3, right 1, up is positive, right is positive, down is negative, left is negative. But here we have 3 over 1, which is that same slope is 3. Now the other way we want to be able to identify our slopes or constant rates of change is when we switch the form of the line. Instead of having this graphical form, we're going to have a tabular form, a table. So here's a table in front of me, and it says the table shown does represent a linear function. It takes all the fun away. Find the slope or the constant rate of change for this function. And so what we have to do is make sure that our slope, which is nothing more than my change of y, y2 minus y1, over my change of x, x2 minus x1, is the same between any pair of points. So what we're going to do is we're going to look at the slope between any two pair of points. I'm going to do it between all of these consecutive pairs of points that I'm given. So when I take a look at my first pair of points, I'm going to start with right here. Change of y would be 18 minus 10. That would be what?
That would be 8.
8. Over 3 minus 1, which is?
Which is 2.
Two.
2. And what number is that?
4.
4. Very good. Okay, so I'm going to write 4. There's the slope. Let's do that again. We're going to go ahead and take a look at the next two consecutive points. Change of y would be 30 minus 18, which is?
12.
Over the change of x, which is?
3.
And that would give us a slope of?
4.
4. So it looks like our slope is truly 4, but we're obsessive enough to not trust it. We're going to go to the next pair of coordinate points, and we're going to say, gosh, my change of y would be?
16.
16.
46 minus 30. That's 16 sounds great. Over?
4.
10 minus 6, which is 4. And that gives us, again, 4. So we must get a 4 if we really have a linear function in this very last calculation as well, will we? Change of y is?
20.
66 minus 46, and the change of x is?
5.
5.
20 over 5 is?
4.
This may be the easiest question I'll ever ask you. Find the slope.
4.
Very good. Thank you. Let's write an equation for a linear function given the graph of y equals f of x shown below. So if I write the general form of a line in point slope form, I get y minus y1 is equal to m times x minus x1. Now, I need to identify 2 points on the graph to find the slope. So I'll identify 0, 2. And I'll also identify -2, -4. So let me find the slope. The slope, which is rise over run, would be the difference of the outputs, y2 minus y1, which in this case would be 2 minus a -4, over x2 minus x1. And if I kept the same order in terms of subtracting the coordinates, this would give me 0 minus a -2. So it looks like my slope is equal to 2 plus 4, which is 6, over 0 plus 2, which is 2. My slope is 3. So I'll substitute that 3 right here. Next, I'll go ahead and substitute in x1, y1. So if I substitute in a -2 for x1, and a -4 for y1, I can now rewrite my equation, which is y minus a -4 is equal to the slope, which is 3, times x minus a -2. Simplifying, we get y plus 4 is equal to 3 times x plus 2. And if I solve for y, I would have y plus 4 is equal to, and I'll distribute to 3x plus 6. So eventually, solving for y, when I subtract a 4 from both sides of the equation, I find y to be equal to 3x plus 2. Now that is one way to find the equation of this line off of the graph. But there is a quicker way. And the quicker way works when you recognize that once you find the slope, one of the points was the y-intercept. So you could write down y equals mx plus b. And then for the slope, you know you're going to substitute in a 3 And for the y-intercept, well, that's just the 2. So I could have gone ahead and written y is equal to 3x plus 2 right off of the slope-intercept form. Either way, the equation of the line is y equals 3x plus 2. Write an equation of a linear function in slope-intercept form if f of 3 equals negative 2 and f of 8 equals 1. Now, slope-intercept form means we're going to have f of x is equal to mx plus b. So what we're going to have to do is we're going to have to first find the slope. Now, to find the slope, I'm going to take the information we're given, which is that f of 3 equals negative 2, and f of 8 is equal to 1, and write each of these so I can see the coordinate pairs. If f of 3 equals negative 2, the coordinate pair that would correspond is 3, negative 2. And if f of 8 equals 1, the coordinate pair that would correspond would be 8, 1. So the first thing we're going to do is find the slope. So slope is given by the change of outputs, change of y, negative 2 minus 1, over the change of inputs, change of x, 3 minus 8. And so this gives us negative 3 divided by negative 5, and we find the slope to be 3/5. That 3/5 will go right here. Next, we'll use the point slope form of a line, which is y minus y1 is equal to m times x minus x1. And for the slope, we'll substitute in 3/5. And x1 and y1 refers to the coordinates of one of these coordinate pairs. And so we're going to take a look at the coordinate pair 8, 1. So the y-coordinate is 1 and the x-coordinate is 8. And we'll substitute into our point slope form of a line. So we have y minus 1 is equal to 3/5 times x minus 8. Now remember, we're trying to write our linear equation in slope-intercept form. Here is slope-intercept form. This means we're going to have to solve for y. So solving for y, the first thing I'll do is distribute the 3/5. So I have y minus 1 is equal to 3/5 at x. And 3/5 times a negative 8 is negative 24 over 5. Last step is to add a 1 to both sides. So if I add a 1 to both sides, I get y is equal to 3/5 x minus 24 over 5 plus 1. And I'll go ahead and remind myself that 1 is the same as 5 over 5. So now I have y is equal to 3/5 x, and negative 24 over 5 plus 5 over 5 is negative 19 over 5. There is my linear function written in slope-intercept form, or if I want to write it more in function notation, I have f of x is equal to 3/5 x minus 19 over 5. Thank you. Marcus currently has 200 songs in his music collection. Every month he adds 15 new songs. Write a formula for the number of songs n in his collection as a function of time t, which is the number of months. How many songs will he own in a year? Well, the key to this problem is that he adds 15 new songs every month. And because of that, this is a constant rate of change. This is a slope. And the slope is 15 songs per month. So this means we have a linear function. And we're used to writing y equals mx plus b. But in this particular problem, they would like us to use a different notation. They say write a formula for the number of songs n, and so this means we're going to go ahead and say that's the output. That's the number of songs. The input, well, it's a function of time. t. So this means we want to find n of t. And this will be equal to m times t plus b, a blue b instead of a red b, a different b here. So substituting in, we know the slope is 15. And b is the initial output. Well, initially, Marcus has 200 songs. So it looks like part A would be n of t is equal to 15t plus 200. Now, how many songs will he own in a year? Well, notice our domain is t, and t is found by looking at the number of months that have passed. I can read that off my units for slope. So what we really want to ask is how many songs will he own in 12 months? So that means we'll take our function n and evaluate it at 12. So we have 15 times 12 plus 200, which means we have 15 new songs per month for 12 months, plus the 200 songs he started with. N of 12 is the result of this calculation. And that would be 15 times 12, which is 180. So we have 180 plus 200. That's 380. So Marcus will have 380 songs in 12 months. Which of the tables could represent a linear function? For each that could be linear, find a linear equation that models the data. Well, linear functions have a constant rate of change, so we're going to see if, with these tables, if we have the same rate of change throughout. So this means when I look at the first table, I ask myself, well, is it linear? Well, what would be the slope for the first two coordinate pairs? Slope is change of output per change of input, so we have negative 10 minus 5, which is negative 15, all over negative 5, all over 5 minus 0, which is 5. For the next two consecutive coordinate pairs, we have negative 25 minus a negative 10, which is negative 15, over 10 minus 5, which is 5. And for the last two coordinate pairs that are consecutive, we have negative 40 minus a negative 25, that's negative 15, over 15 minus 10, which is 5. So it certainly looks like we do have a constant rate of change, and that slope that we have is negative 15 over 5, which is negative 3. So the first question, which of the tables could represent a linear function? The first one can. I do have a linear function. Next, I want to find a linear equation that models the data. So I'm going to write my general form for a linear function, f of x is equal to mx plus b, and I need to identify the slope. Well, that I know, that's negative 3. And I need to identify the y-intercept, which I'll glean from the fact that I have a coordinate pair 0, 5. So the y-intercept occurs when the input is 0, and so that means my output is 5. And so my y-intercept is 5. So my linear function is f of x is equal to negative 3x plus 5. Looking at the second table, we do have a function. Is it linear? Well, again, I'm going to see if I can detect a constant rate of change. If I look at the first two coordinate pairs and look at a change of output over change of input, I get 30 minus 5, which is 25, over 5 minus 0, which is 5. Next two consecutive coordinate pairs, well, the difference of the outputs would look like 105 minus 30. That would be 75, all over 10 minus 5, which is 5. And notice these are not equal. So that means I don't have a constant rate of change. So my conclusion is that this table that represents a function does not represent a linear function. Thank you.